Hey guys, so this, what we have right here,
It's laminar flow.
laminar flow, and it's under high pressure. This is meant to represent the arterial system. All right, so what I have here now, Zach, have a look. These are my helpers, Max and Zach.
Okay.
This is packed tight with a sponge, all right?
Yes.
That represents a lot of resistance. That's the capillary system. So it goes from your heart out to your limbs through all the capillaries, and the capillaries drop the pressure down. So what's going to happen next, when I put this on, it's going to have to go through that high resistance system, and you're going to push this to a spot that doesn't soak you. All right, you ready for this?
Okay.
I don't want to soak Oma.
Alright, well, this is not gonna soak me.
All right, no, let go, let go, let go. All right, here we go. This is the venous system here, all right? So when you have blood coming through the veins is a lower pressure system here, okay? Oh, there's the help, there's the help. This is a venous, okay, that's a venous system there. Now, watch what happens to this. Where is my tourniquet? This is a tourniquet, all right? So when I am squeezing this,
yes, that means there's going to be a bubble.
even as I squeeze, it's the venous system that compresses first. And look what's, okay, momentito, Rodrigo. As I squeeze the venous system, there's pressure that builds up. Look what's happening there. There's a lot of pressure in that
when I
venous
squeeze
system.
it.
Now I'm going to release that. Here, let go, let go, let go. All right, there's a lot of pressure that builds up in that venous system. Now let's look at this other thing here. Let's look at this. Move out of the way. What I'm going to do, I'm going to make a hole. This is an arterial hole here, okay? There. All right. All right, so what's happening here? I have a laceration, a laceration in an artery.
Laceration for real.
So right now, what I'm going to do is close this off. And if I don't, here, let's constrict this. Now look what's happening here. The venous system is building up. The arterial system is not doing anything. So I just have back pressure. And look what's happening there. My venous system is building up, arterial system, nothing's happened. So I really have to make it constricted. All right. Oh, that's a better representation of a flow. So now wait a second. All right, now I'm going to do this again.
Again.
All right, so here I go. If what I do is just stop venous flow, but I don't stop arterial flow, what's going to happen? First off, my patient is miserable because their veins are now expanding. And I have even a higher flow out. Look at that. Their veins are expanding, they're miserable, and I have even greater flow out of that. So what I have to do is get this down to constricted completely.
What? Two bubbles. Two bubbles.
Okay. Holy smokes.
Okay,
You see, it doesn't, don't get on my way. I need another clamp. I need more resistance.
Three bubbles. Three bubbles.
Are you kidding me?
There's three bubbles.
It's gonna blow.
It's gonna blow.
Holy cow, I need another clamp. This is a high pressure system.
Okay.
I need another clamp.
I look at the sausage bubble. Look. Look at this. It's so hard. 5.
What if I just,
There's 5 bubbles.
if I clamp it like this? All right.
Look at the sausage bubble. There's so many bubbles.
All right, so
It's
stop.
not stopping.
Not stopping. There's so much built up pressure in this venous system now.
This is like,
Zach, you better just turn off the water flow.
I don't know how.
You don't know how, just turn it off. He did it, he got it done. Hey again, my friends. So today is just a summary of the experiment that I tried to do with my kids yesterday. I'm just going to go through the steps here. So what I have is a high pressure system. This is the arterial system. In here I have tightly packed sponge that's meant to represent capillaries. And then through this tube is a low pressure trickle. All right. And what I'm trying to convey is my philosophy, my perspective on tourniquets, and why I'm a fan of direct pressure versus tourniquets. I think tourniquets should only be used in the cases of partial or complete amputation where this experiment is irrelevant. But tourniquet use in the absence of direct pressure, I think, can make people worse. And this is what I'm trying to convey. So if I have a vein and an artery, low pressure vein, high pressure artery there, as I'm constricting, what I'm doing is first closing off that venous system. And it takes a while to make any change at all in the arterial system, even though I'm constricting it. And you can actually see there's increasing flow. And what's also happening here is I have a lot of increasing pressure in the venous system. So that's a lot of the pain that people go through when they have tourniquets applied. And right now I'm constricting. I have the arterial system clamped down quite a bit, but not all the way. So even if there's just a little bit of a leak, my patient is being made worse. And I have all kinds, so that's as tight as I can make this. And it's spurting even more because now I have a high pressure venous system. So what I'm gonna do is put even a second tourniquet proximal to the first. And now I'm gonna crank this down. And this hopefully will stop the rest of the flow, but it may just slow. Okay, here we go. There it is. All right, that slowed quite a bit, but now I still have back pressure here. So essentially when you put a tourniquet on, you're committing all the blood that's on this side of the tourniquet to potentially being lost. So you're potentially making somebody worse. What's an alternative to that? Direct pressure on the hole. So my philosophy is, oh, I still got a little bit more. Oh, I need a Slishman Pressure Wrap. Anyway, direct pressure first, then do your tourniquet. That's all. Bye.